Hey, welcome to the Lemon Lattice software skills video. This is the first video in our series, and this is the introduction to Autodesk Meshmixer. This is a really nice organic CAD modeling system. So any of our limb shapes, things working off of a mesh rather than dimensioned like mechanical parts, which you would use traditional CAD software for. So we're going to start. First thing we're going to do is import. So import's going to bring in a scan model, whereas open is going to open a previous Meshmixer, what they call .mix mix files. So we don't want a mix file, we want to import a scan. So you can see right there a mix. So we're going to bring in this. This is an OBJ file. I use OBJs out of my scanner, which is the Scandy Pro app on the iPhone. And the reason I use those is because they show you the color map, the texture here. So STL files do not show you that, but OBJ and PLY files do. The other file type you might see around is a 3MF, which also carries color as well as material data, dimensions, and other things like that. So that's an evolving file, especially in the 3D printing space. So that's a really nice one to use when you have the chance, and we'll see those throughout our different series here. So we have this view. If you hit the space bar, it's going to pull up this menu, and you can click back and forth. So if you click that one, you'll see this is more like what you might be used to seeing in a program like Tracer or Omega. Or if you brought in an STL file that doesn't have a color map, you'd only see something like this. Whereas, because we have an OBJ and we go to color, you can see that from my plaster model I'd worked on, I was able to draw my trim lines, mark out my bony anatomy, different things I wanted to do. So I really like OBJs for that reason. The other view, which you saw a minute ago, if we go up here, top toolbar, view, and that is show wireframe. So you can also do the hotkeys, in this case W, or you can just click it here. And that wireframe shows you your actual mesh density. So each one of these little triangles represents a facet of that mesh. And the denser those triangles are, the more accurate your mesh is, but also the more intensive it is on your computer to process and work with. So bottom right corner, you can see triangle count a little over 26,000. And if we wanted to change that, there's a couple ways. You can do select. And when you pull up that select tool, you can select individual triangles. You can make your selection tool bigger and do those. If you hit escape, it'll clear everything out. Or you could also do Control Z and undo the last, or hold Control and that'll actually delete some of your selection set. So escape. You can also do double click on a model and that'll select all of it, or Control A will select all of it. So once we have that, we're going to go up here. It's going to pull up. So select, double click, it pulls up this menu here. We'll go edit and reduce. So I don't want to remesh because that's a really intensive process that sometimes different computers can struggle to handle, especially based on your triangle counts. So let's go to reduce. And this one is pretty easy for the computer to handle, especially at these relatively lower triangle counts. Once you get up over like 100,000 or more, which a lot of the scans you might take could be way up there. So you might have to reduce those right off the start, or do it in your app if you have that option like you do in Scandy, which there they call it decimate. So once we're in the reduce tool, a couple different options of how you can do percentage and change it there. So a higher percentage reduces it more. I like triangle budget. Let's call it 20,000 to start. And then you can also do uniform or shape preserving. So shape preserving is going to have some small, some big based on your contours, whereas uniform is going to try and make them all match, which we'll be able to see easier here at a lower number. So I just type that in, hit enter, and that'll update it. So that's uniform. You can see shape preserving is a little different. So let's stick with that. We'll hit accept. And we've now reduced our mesh count without really sacrificing any accuracy to make this easier to work with. So we're going to hit escape, unselect that, W, turn that off. So the next thing we need to know is how to navigate. So if you're just using a mouse, it's going to be, you can use your wheel to scroll in and out and zoom. If you hold the wheel and move, you can pan left and right. And if you right click and hold, you can rotate. And then left clicking is going to be your different tools and interactions. I use something called a space mouse from a company called 3D Connections. And that allows me to rotate and move the model freely with the space mouse, which is in my left hand, while my right hand is free to use the tool based on whatever I'm using at the time. So that really speeds things up and makes designing a lot easier having that space mouse there. Top right, you can see we have our view cube. Let's hit home. So this always comes back to what's called home position here, the corner between the front, right, and top. If you click one of these faces, it'll take you to that face. And if you click the arrows, it'll rotate you around, and the curved arrow will rotate on that axis. So you'll notice we're not aligned right now. To do that, we're going to come over here to Edit and Transform. So that's going to allow us to move. This little green S is snap. And what that does is it keeps this dial to where you're moving in certain increments. And if you're inside that dial, you can move freely. Whereas if you have it on it, it's going to snap to them. I don't really like using snap, particularly for moving up and down like this. So I like to turn that off so that I can just move freely. But let's get this position. So I like to just start with home, and then I go world frame over here on the left. So world frame's traditional X, Y, and Z axis. Local frame is going to be relative to your model. So world, and then you just grab and drag these. So those ones will rotate. If you grab the arrow, that'll slide. And if you grab this little triangle, that's going to pan across that plane. So it'll move you in two directions at once on that plane. So let's just rotate this and roughly get this into our starting alignment. And we'll go there and accept. So we've got it now aligned. See, we like where we're at. We know how to move it. We know about meshes. The next thing we want to do is figure out, do we have the right dimensions on this model before we start working on it at all? So you're going to come over here, again, left toolbar, analysis. You're going to go units, dimensions. So you can see this is telling us we are X dimension, so 145. It's got the Y at 313 and the Z at 117. So these are a little different from what you'll see in a slicer or other software where your X is left, right, your Y is front to back, and your Z is up and down. And this just might be some settings I have in here. I don't really ever look at how they're labeled, so I don't worry about that much. I just look at them here on the actual model. So we've got what we want. We're 313 millimeters tall. That seems appropriate. If we click these, we could actually change that. So if we hit that, say you're in the wrong one and you need to get to what you need to be. So if we go keep, that's how, that made us 313 meters tall. Whereas converting will actually change you Um, it won't change the size of your model, it'll just change your units. So I'm going to go Control Z and try to undo some things, Control Y here. So let's go back to that. Yeah, see, we're huge. So we're going to go meters, convert, millimeters, keep, and that should put us back to an appropriate size. So if you come in inches or centimeters or whatever you need to be, just work to get yourself to whatever units, and I find that millimeters tend to work best. So in doing that, I lost my alignment. Let's put it back real quick. And that's because I hit Control Z too many times. So we'll go with that for now. So we've got that. Next thing to figure out is, again, analysis and inspector this time. And this is going to show us any issues with our mesh, any holes. So this big blue ring tells us that the mesh is open at the top, and you can see that inside black and gray striped surface is the inside of your surface. And then pink are going to be these little free-floating island pieces, and red are another type of hole, a little bit more of a complex hole compared to a blue. So you can come over here to the left. You can do minimal, flat, smooth. Just try different ones out and find what you like. And that's the same thing with a lot of these tools. There's a lot of ways to do things within Meshmixer. You just got to find the way that you like. And that just comes through trying things. So you can hit auto repair all, and it'll go through and try and clean up all of this. Or you can click the individual sphere and clean them up one at a time. So those, it's going to get rid of these little islands. I'm just going to leave that top open. That doesn't matter right now because I would work with it that way until a later step anyways. So done. And then let's go through real quick cleaning up some of this this messiness that might come in on a scan. So if you had some other ones where maybe you had a tabletop in it, you could do things like edit and plane cut and cut away a whole section above or below. You can flip it with this arrow here, and then you can also rotate that plane to cut different things. So it'll keep this and it'll cut the ghosted side. So we're not going to do that right now. What we want to do is actually just clean up this little spot. We don't have big things to get rid of. So you could always select things and just hit delete and get rid of them, and then try to close that hole. Or there's kind of an all-in-one tool that gives you some options. So if you select all this stuff and come up here to edit, erase, and fill, then it'll just get rid of the messiness and try to keep your boundaries. And you can kind of dial it in with scale and bulge and these other sliders to get it to be something like you think it should be, knowing your model and what you want. And it might be a couple steps. So like that got rid of the bulk of it, but we still have this. So we'll just do it again and clean that up. So that'll get you started working with a model. Try those things out, and then in the next video, we're going to get into some of the actual skills and tools. I'll show you there's all sorts of stuff here. There's all these different tools that we'll go through and figure out how these things work and how to use them. One other thing about Meshmixer, it's not great with measurements. It's got this measure tool, but it's not particularly useful or easy to work with. So Meshmixer is more of like an artistic tool. It's not going to be great for measuring circumferences or doing modifications that way, but you could do things like sculpt down or build up. So there's ways to do modifications, and those tools will be used in building things, but they're not great if you're trying to do like a certain millimeter amount reduction circumferentially. What you could do is edit, transform, And you could always change this just by scale. So if we take that and we go 0.97, that'll be like doing a 3% reduction just across that axis. So you see that one, how that moved left to right. So by doing it left to right and front to back, I've done roughly a 3% volume reduction on that model without taking off any length. So you could do uniform scaling if you just want to do them all. Say you want to take 3% off everything. Edit, transform. You can do uniform scaling. If you come in there and hit 0.97, it's going to change all three together. So X, Y, and Z axes. So use those, try them out, and then we'll get into the tools next time.